So as I stated before, my project is on the geothermal plants in New Zealand. 80% of New Zealand's electricity comes from renewable sources. Now, this is just the electricity. This 80% makes up about 40% of the total consumption of energy in New Zealand. So that number is offset, of course, by transportation like cars and trains. Of that 80%, 14% of it exists purely as geothermal power. And this is to be expected as the country New Zealand is located right on the southern hem of the Pacific tectonic plate, so it would be prone to a lot of volcanic and seismic phenomenon. All right. So of the of the many locations in New Zealand, I created a list of the most notable ones within the Taupo volcanic zone. For example, Wareki is okay, and also before I start pronouncing these, of course, I'm going to butcher quite a few names. So again, sorry for that in advance. Moreki is the location of the first geothermal plant. Mokai is is another geothermal plant owned by Taropaki and maintained by Mercury. Rotokawa has a notably larger temperature vent than other sites, and I remember reading somewhere in my sources, I can't remember where, but there are traces of extremophiles in that vent, of Rotokawa's vent, and extremophiles, of course, being those microbes that can live in stupid, crazy environments like the vacuum of space, and in some insane cases, like molten magma. So yeah, Kawaru is the location of the largest plant in New Zealand. Naga Awapura was constructed with a trust between 800 different owners. Naktamakari was the site to encounter the first pluton during drilling, and from what I've read, a pluton is essentially just a geological structure consisting of volcanic ash. And finally, Tamihi was built to siphon power away from Wareki and eventually replace it overall as a power station. Let's see. All right, so I created, I went into further depth with 3 additional sites, as they were more interesting than the others, of course. So, yeah, first off is Wareki, which was built in 1958 in the northernmost region of the Taupo volcanic zone. It is the first wet steam geothermal plant in the world, and of course, as I mentioned before, the first geothermal plant in New Zealand, so that's pretty big. It is operated by Contact Energy. It is the site is home to the substations responsible for connecting more than half of the nation's power grid together. So, again, this is a pretty historic location. Early usage of this site caused local ecosystems to change until the power draw was eventually capped. These changes include upsurges, steam upsurges, and local areas like the craters of the moon. So, of course, people dialed that back and they started getting freaked out. Alright, moving on. Kawaru is located next to the Bay of Plenty in the Kawaru geothermal zone, which is really just a northwestern section of the, northeastern section of the Taupo volcanic zone. So, yeah. It was built in 2008 by Mighty River Power with a $300 million equivalent budget. They, of course, obviously being in a different country, didn't purchase it with US dollars. So, yeah. After its construction, the capacity was proved to be much larger than the initial survey suggested, and ended up being the highest capacity single generator project in the country at 100 megawatts. Now, mind you, the site itself is beat quite significantly by Wareki, of all places, at 170 megawatts. The reason that this is the site of the largest generator is it is the largest single generator, mind you. So, of course, Wareki is split up between multiple generators. Kawaru has one single generator. Now, of that, Kawaru also co-supplies a local paper mill with lower temperature, lower pressure output steam to, well, obviously make paper. All right. Third on our list is Tamihi. It was constructed. Its construction took place between 2011 and 2014, and it costed a U.S. dollar equivalent of $623 million. And here are three more names that I'm going to butcher, but here we go. And the entire plant was designed and constructed by a combination of McConnell Dowell, SNC Lavalin, and Parsons Brinkerhoff. It was built near the Lorikeet geothermal plant as a means to siphon away power from the site and eventually replace it entirely. As of right now, Tamihi has decreased the capacity of Lorikeet by 45 megawatts, and the current capacity of Tamihi itself is almost 170 megawatts. I think the exact number is actually closer to 166 megawatts as of right now. All right, so moving on, I go into more depth of the actual designs of these sites. So, as I mentioned before, Lorikeet was a wet steam geothermal generation site. What defines a wet steam geothermal site is, first off, the aquifer connected to it typically measures around 200 degrees Fahrenheit. Now, high temperature groundwater from these wells are brought up and is depressurized as it depressurizes to the surface pressure, and during this, some of the water flashes as steam, where it is used to generate power. The remaining liquid is either pumped back down or used for space heating applications, or I guess in some even crazier applications, co-supplying, like that paper mill. Alright, design 2. Kawaru uses a unique two-phase fluid geothermal generation site. I wasn't able to get an actual schematic of it, but essentially, as the fluid is drawn from the well, all of it flashes as steam, and it is separated into high and low pressure steam. These two streams are then each sent to their own location to maximize efficiency. Ignore that upstairs. The high and low... Okay, so the high pressure steam, of course, goes to the generator on site, while the low pressure steam, as I mentioned before, goes to the paper mill. Alright, design number 3, Rotokawa. As I mentioned before, its vent is much higher in temperature than the other locations, ranging well over 300 degrees Fahrenheit, and this technically categorizes it as a dry steam geothermal generation site. Of course, as I just said, what defines a dry steam geothermal site is that it has a very significantly higher temperature than other sites. So when the steam is extracted, it already exists in a supercritical state, which of course is very good for generation purposes, as you can squeeze more power out of it. All right, now design number 4. There are no hot water sites that I listed. However, it's important to note, as it is the third technical categorization of a geothermal plant. So hot water geothermal generation is essentially just glorified, a glorified heat sink. Water ranging from temperatures between 150 to 200 degrees Fahrenheit is extracted from the ground, and because of the lower temperatures, none of it ends up flashing to steam. So once it's drawn up, it's used for space heating applications or for industrial purposes. Now, depending on what kind of site you use, if it's a volcanic site, of course, it'll be heating it, but you can also use it for cooling applications. Basically, it'll just equalize the temperature of whatever it's hooked up to whatever the ground temperature is. So, yeah. Like I said, glorified heat sink. And that would be it. Here are my sources at the final page. You can look at them at your leisure, and that is it. Bye.